Hey everybody, this is Miss Sorrells. We're going to be doing video 14.2. You should have these notes out in front of you, and you also need your foldable. We're going to actually start with the foldable, so I'm going to set these aside. You need to get your foldable out, and you're going to flip to the back. And I want you to pause this and write this down, and that way I can explain this. Today we are going to be talking about the difference between independent and dependent variables, okay? Remember that this is your x-axis, and the way I like to remember is x to flex, okay, and then y to the sky. Y goes up and down, okay. So label your x and y, and then label this. The dependent variable will be on the y-axis, and the independent variable will be on the x. Okay, so pause this, and then I'll explain a little bit to you. Okay, so the difference between independent and dependent, and I'll go into more details in a little bit, is one of these can stand alone, meaning it is independent, it is by itself. So the one that can be by itself is independent, and dependent means it depends on the independent variable. Something happens when the independent variable changes. It's a cause and effect relationship. Okay, so now I want you to go ahead and get these notes out, okay, and follow along. Alright, for all you visual learners like me, I like to use visuals to help me. So this is the independent, and I have colored in the I because independent, they stand alone, meaning it can be by itself, and it's okay. The dependent, look at the word I've underlined. In the word, it says depends. So this one depends on something else. Okay? I know this isn't your notes. This is just to help you out. Write it down if you feel like you need to. Alright. Alright, we're going to be going from tables to equations to possibly a graph on this. What I want to start with is we have got to identify our independent and our dependent variables. So let's look at what we're comparing. We're comparing rain to plants' growth. So the question you would need to ask yourself is which one depends on the other. For instance, if the plants grow, does that automatically mean it's going to rain? So this would be the cause, and the effect is that it rains. Or is the cause rain, and the effect of the rain would be the plant's growth? And that's the way it works. When it rains, the plants are able to grow. So the rain will actually be the independent variable. Okay? And the plant's growth depends on how much it rains. So the D stands for dependent, is the plant's growth. Okay? Here's another connection you need to make. The independent variable is always your x variable, or the one that goes on the x-axis. It's the independent, okay? Plant's growth would be our dependent, or our y, okay? So I want you to fill these in with me. So it says, okay, if it rains 1 inch, then the plant's going to grow to, let's make these inches. It'll grow 2 inches. 2, 4, let's fill in. What if we have 2.5 inches of rain? It'd be 5, 3, 6, 3.5, 7, 4. Okay, and we could keep going there. Okay, this would be 8. Let's just stop there. Okay, you can leave those other blank. Now, we've identified our independent, our dependent. Now we're going to kind of spiral back and say, okay, let's make this an equation. So is this a multiplicative or additive relationship? In other words, how do you get from x to y? So if you're looking at the relationship, 1 plus 1 is 2, but if I do 2 plus 1, is that 4? No. So it's not additive, it's got to be multiplicative. So 1 times 2 is 2, 2 times 2 is 4, okay, times 2. 2.5 times 2 equals 5. So this is a multiplicative relationship. From there, now I can create my equation. What am I doing to my x? It's going to be y equals, because this is the dependent, it depends on something. And what are you doing to x? You're taking these x values and multiplying them by 2. So we could write this as 2x, because that means x times 2. You always write the number first. From there, y'all, you could actually graph this. These would be your coordinates, just like y'all did a couple days ago. So these would be the coordinates you actually would put on the graph. And for time, we're not going to do that. Okay, the other thing I want to explain is it's like a Gumball machine. This is an input-output machine here, okay? You put something in and you get something out. If it rains, you get this. If you put a quarter in this machine, it will spiral down and out will come a yummy gumball. Okay, it's the same concept. Something has to happen for something else to happen. Alright, let's see what you've learned so far. This is Google Doc question 1. You've got your graph here and you're telling me which one is the independent variable. Is it the coins or is it the gumballs coming out of the machine? So coins used, gumballs coming out. Okay, good job. Google Doc question number 2. It's the same table and then you're going to answer this question. Okay, which of the following could be a correct equation? We found the independent, the dependent. The next step is equation. Alright, next number 2. Now we're looking at a graph, which we like this. This is fun. We are comparing. You always want to look at your axis and see what you're comparing. You're comparing minutes walked and calories burned. And I've learned from the foldable that this is always going to be my independent and this is my dependent. So the calories burned depends on how many minutes I walk. Okay, so over here we know our input is X, or it's our independent, and this is Y, or our dependent. Okay, so this is easy. All we're doing is taking these coordinates and you can put everything into a table. That way the equation is a lot easier. It's hard to write an equation from a graph. Okay, so this point right here, the X is positive 1 and that's in between the 2 and the 4. So this would be 1, 3. This is the X-axis is 2 and you go on the Y-axis up to 4. Positive 3, positive 5. Okay. On the x-axis positive 4 and that looks like a 6, and then 5 and just a second, mine's not as clear as yours should be. It would have been 5 and 7. I don't even think you have that one. So now these are my points that go in here. This is my X, this is my Y. So 1 minute is 3 calories burned. 2 minutes is 4 calories burned. It's the direct relationship here described through a table. So now let's pick if it's multiplicative or additive. Okay, it's one of the two. So process would be, if it's multiplicative, 1 times 3 is 3. Now if I do this X, if I do 2 times 3, do I get 4? No, so it can't be multiplicative. It's got to be additive. Let's figure it out. 1 plus what is 3? Plus 2. Is 2 plus 2 equal to 4? Yes. Is 3 plus 2 equal to 5? So this one is actually additive. And we just found our equation. What are you doing to the X each time? You're taking the X value and adding 2. So this would be Y equals, you can write 2 plus X. Whoa. Or you can write Y equals X plus 2. You can even write X plus 2 equals Y, or 2 plus X equals Y. All of them are acceptable addition. The order doesn't matter. Okay, so we just went graph, table to now equation. Alright, let's check what you know. This is questions 3 and 4 for the Google Doc. So the first question is, which is the dependent variable? Is it the number of people in line compared to the time you have to wait? Or is the time you have to wait depend on the number of people in line? So figure out the dependent. And then number 4 says, which of the following is not a coordinate? So a review of last 14.1. Which of these is not a coordinate on this coordinate plane? Alright, now you're going to look at this last one. We're going to look at the table first and the graph in a minute. Alright, so we've got, as an airplane increases into the air, which is called altitude, the pressure declines, or it decreases. Okay, so you have a table here. We have to decide which one depends on the other one. So it tells you when the airplane increases, the pressure declines. So this is a perfect example of cause. This is the cause, and the effect is that the pressure declines. Which that means, this would say declines, that means this is the dependent and this is the independent. So independent is the altitude, dependent is the air pressure. How much does the air pressure change when you go up in the air? Alright, so now we've got an X and Y table. This is your X, this is your Y, and it's not, it's up and down now, okay, it's vertical. So we have to figure out, how do we go from here to here, from here to here? This one is actually multiplicative. or it's really division, but division can always be multiplicative. And to go from the x to the y to save us time, you are actually dividing by 50. 1,000 divided by 50 is 50, 2,000 is 50. So to get y, or your air pressure, you take this x value and you divide by 50. Okay, we could also write it like this. Okay, from here you can graph your points. Now, I want you to graph your points on your own, but I want to note something. This is like 1,000, this is 2,000, this is 3,000, 4,000, and then pay attention to these increments. Okay, pause that, try it, and then check your answer. All right, notice that this is in quadrant number 4, and it's because the pressure is decreasing, so it puts it in that -1. We wanted y'all to see an example, a real life example that would be outside of quadrant 1. All right, you have one last Google Doc question, and then you are done. Here it is. As the submarine dives deep down in the ocean, the water pressure increases. So very similar. Which equation can be used to describe this relationship? Now I'll go ahead and give you a hint. This is your x, this is your y. Okay, so how do you get from here to here? Pick your equation. Alright, that's it. That's a wrap. We will see you in class. Bring your foldable and make sure you click submit on the Google Doc. Y'all have a good night.